Hello, my name is Tae-ryang Jeon, and I'm a manager at Busan Port Authority. I will present the Digital Twin Integrated Platform in today's lecture. First, I will introduce Busan Port. It is currently the 6th largest container port in the world, and it is a transshipment-focused port with 60% of total cargo being transshipment. As of last year, Busan Port handled a total of 21 million containers, of which 12 million were transshipment cargo. Busan Port's goal is to attract more transshipment cargo and to handle it efficiently. We plan to make Busan Port more efficient and create a better environment for transshipments by adopting the Digital Twin Platform. The target site of the Digital Twin Platform project is at Busan New Port. Busan New Port was opened in 2012, and there are currently 23 berths in operation in 6 terminals, and a total of 45 berths scheduled to operate by 2040. This project will be carried out on the 3 berths at the PNIT terminal. I will first cover Busan Port's information system here, and then move on to the digital platform. The first port information system developed is the PortMIS, developed in 1996. It had drawbacks in reliability as it was susceptible to inaccurate data provided by ships, shipping companies, and terminal operators. The BPA NAT was developed in 2012 by BPA, and reliability has increased by adding EDI data to the existing PortMIS data. The Chain Portal was developed in 2019, which added individual data of terminal operators and loaded truck data to reflect the terminal operation status. The first data that the Chain Portal is focusing on is ITT, which means Inter-Terminal Transport Service. 6 terminal operators are operated independently at Busan New Port, so there are many cargoes moving between different terminal operators. For example, HMM unloads at Terminal 1 and Maersk at Terminal 2. However, transshipment cargo arriving at Terminal 1 has to leave from Terminal 2, and therefore, if the number of cargo transshipment is reduced and interlinked, Busan New Port will be less congested and enable additional cost savings, which will further enhance the port's competitiveness. The second data is terminal operator data. Terminal operators are private companies, so it is difficult to receive data from them. But under the condition that BPA provides the ITT service, terminal operator data could be obtained, and the ITT service is provided in connection with this. The third data is the integrated data between the ITT service, terminal operation data, and big data. It is possible to analyze information such as what type of cargo comes into which terminal, and at what time, where the cargo is headed most, or which shipping company handles the most cargo. Based on the data mentioned earlier, BPA is developing a digital twin platform. The Digital Twin Platform project is carried out for a total of 9 months, from April to December 2021, this year, and will be carried out at the 3 berths of the PNIT terminal in Busan New Port. The total budget is $3 million, and the project consists of a total of 4 tasks. Task 1 covers port call optimization and safety. Task 2 covers terminal operation optimization. Task 3 covers the optimization of the inland logistics. Task 4 covers building a platform that integrates tasks 1, 2, 3. I will discuss more about the Digital Twin Platform project in this section. Task 1 covers port call optimization and safety of ship. Until now, it was difficult to share and check the estimated arrival time of the ship and operating status of the terminal. For example, Ship A is scheduled to enter Busan Port 1 hour later than it originally scheduled. However, since many ships have already entered the port, and the terminal is open 24/7 for 365 days, it is not possible to adjust the time for Ship A if it arrives late. Therefore, Ship A must not arrive earlier or later than scheduled in order to match the terminal operation time. But if the ship sails at high speed to arrive on time, its fuel consumption will increase, which causes higher fuel charge and air pollution. Therefore, through Task 1, we would like to provide services that can ensure the operational stability of Busan Port and enable shipping companies using Busan Port to arrive at a more convenient and desirable time. In Task 2, we plan to derive how the terminal operator should respond according to the arrival time of the vessel. For example, if Ship A arrives at the PNIT terminal 2 hours late, the system derives how to operate the 3 berths of PNIT. Task 2 enables to derive the optimal solution to improve productivity based on Task 1 data by considering the departure arrival time of other ships, inputting all data such as berth and the current work status. Data such as the changed arrival time of the ship and the operating time of the terminal derived from Task 2 are transferred to Task 3. In Task 3, if there is a truck that needs to arrive by 3 p.m. to load the cargo arriving at the terminal, and the cargo arrives 2 hours late, the truck can arrive at the destination through the best route in time by avoiding heavy traffic to load the cargo. All this data is linked into the integrated platform of Task 4, and an optimized alternative is derived through coordination between data from different tasks. The derived solutions will be shared among stakeholders. Now we will go over the details of each task. In Task 1, we plan to utilize data, such as port miss, and chain portal and VTS, ship location information, and GIS. In addition, information from the first smart container ship built in Korea will be used to provide information on the ship's fuel consumption, operating speed, ship condition, and climate data. Based on this data, it is possible to calculate the expected arrival time of ships entering the port. The first subtask to be performed in Task 1 is to create a dashboard. We plan to create a dashboard that allows BPA to manage all the data of ships, ports, and hinterland logistics, which were previously managed individually, so it enables to check Busan port's operations at one glance. The second subtask is to optimize the ship's departure and arrival time. For example, it will calculate the optimal time of arrival and will transmit the data of the ship. The third subtask is to build the GIS platform. Information such as current weather, navigation, and marine will be collected and visualized in 3D to determine the impact of Busan Port on marine climate or air pollution, and this information will be confirmed through the dashboard. Task 2 is port operation optimization. We plan to utilize the terminal operating system data and location information of yard tractor. So far, there is no location information for yard tractors. We want to implement an efficient system through real-time location tracking of YTs in order to solve the complex movement and inefficiencies between YTs. In addition, until now, the terminal operating system data has not been accessed or utilized by BPA because it is the individual right of private companies. Through this project, we have been provided with TOS data in cooperation with the terminal shipping companies. We plan to build a system that connects ships and hinterland logistics, and to build a 3D virtual terminal. For example, it is difficult to judge what kind of operation and interference occurs in each individual layer between the YT's operation flow, but it is made possible to check where CC interface occur depending on the YT's flow when the digital twin platform is implemented by combining all the layers together. Task 3 is hinterland logistics optimization. It calculates the real-time location of trucks entering Busan Port, time and location of departures, routes, and estimated time of arrival. When it comes to terminal operations, the most important job is unloading, so trucks arriving at the yard to load cargo are always on standby. It will enable to work faster through terminal work information and truck operation information. Busan Traffic Information plans to calculate the ETA and RTA with TMAP. It aims to shorten truck stay at the terminal, reduce traffic congestion, and lower air pollution. Lastly, in Task 4, we plan to build a digital twin platform. The result is as follows. First, real-time monitoring becomes possible. It is possible to identify the location of the vessel, the unloading location and scheduled time of the vessel, whether it is later or earlier than usual, and whether the truck should go early or late, and sharing information is possible. Second, based on this information, an optimization algorithm is derived. Through integrated optimization, Busan Port can become a more efficient port without any damage to stakeholders. Finally, it can measure the impact on air pollution. Currently, there are 12 air quality monitoring stations in Busan New Port. We plan to implement the information in real time as digital twins and measure what type of port operations pollute air and measure the effect on the surrounding area of Busan Port through an optimized predictive model. Let's take a closer look at the Task 1. Although everything is not displayed due to limitation of the screen, you can check the location, speed, ETA, and RTA of ships arriving at Busan Port from their departure point. Also, when a ship arrives at Busan Port, a board displays the time of the pilot's arrival, and the shipping company can receive the berthing and departure time. The system provides the information of the ship's tonnage, ship type, and departure arrival route in Busan Port for the past 3 years, and enables to derive the safest route for the ship. Route optimization simulation is calculated through ocean currents, weather, ship tonnage, ship type, and cargo volume. The 3D modeling on the left-hand side displays the type of ship alignment and the number of container cargo, and enables to simulate the crane operation based on the ship type. The right-hand side is a route simulation, and we plan to enable deriving the optimal route. In Task 2, it is possible to check the work activity, current location, and productivity of each cargo handling equipment, such as container crane, transfer crane, and yard tractor. As shown on the left-hand side here, you can check the location and work status of all equipment. The dashboard on the right-hand side displays productivity, task, work volume, and more. In Task 3, city traffic is the most important data. For example, if the road is at its busiest time at 6 p.m., the shortest route to arrive at Busan Port is derived by avoiding operating at 6 p.m. and deriving a way to avoid the congested route. ETA is calculated and reflected in terminal operation, and container yard COI schedule is adjusted accordingly. The yard schedule is introduced to ship operation, and finally reduces the turnaround time of trucks. This is a schematic of ETA and RTA of Task 3. The system provides information such as the most efficient route for trucks when a specific vessel departs for Busan Port. The information is provided to each truck and terminal operator by drawing a link with the yard operation schedule. This concludes my lecture, where we have covered the Digital Twin Platform project in progress at the BPA. Thank you for your attention, and I will be glad to answer any questions you may have.